y'all. So 5.1c lesson. You're definitely going to need a calculator for this lesson. There's lots of kind of yucky numbers and money. That would just be a lot of time spent unnecessarily if you don't have a calculator. So make sure you have a calculator as we get started. Okay, now we are comparing and using unit rates. Okay, now remember from what we just learned from 5.1b, a unit rate has a 1 of something on the bottom of the fraction, okay? Or on the right, if you write it like this, per 1 hour, okay? All right, so looking at this first example, 231 miles in 7 hours, 231 miles per 7 hours. This is the rate. This is the rate that's handed to us. Now we want to find the rate in miles per hour. That means 1 hour. Okay, so what you're going to do is you want to find out how many miles per 1 hour. So wouldn't you be dividing this by 7? Divide by 7 here and divide by 7 here to get 33 in your calculator. Okay, that's how we work these. Now, if you want to pause and work on, say, the next maybe 2 of them, number 2 and 3, and then look back at your answers. If you understood this one, give those a shot on your own. Okay. All right. So we've got 375 students. Do not forget to write your units. Don't be lazy on that. And we've got 12 teachers. And we are asked to find the rate in students per teacher. Now, students per teacher means we want a 1 down here. Okay, we want 1 teacher. Okay, and I'm going to choose to write my unit rate as a fraction form rather than this way. Doesn't matter, you pick. Okay. All right, so do you understand that we're dividing by 12 on the top and the bottom? Okay, we're dividing by 12. Dividing this by 12, and we're dividing this by 12. I just have more space to write it over to the left there. All right, 375 divided by 12, it comes out to a fraction or a decimal. 31.25 students. I know that that seems funny to have a piece of a person, okay, but it happens. It happens when I configure how many desks I need for my students in here. Okay. Some of my classes, I have 30 students in, some I have 28 in. Okay. Some I have 32 in. If you average all those, I'm going to find that I need a certain amount of desks. Okay, and then if I have a portion of 1, then I need to round up to that nearest desk to make sure that I'm covering everybody. Okay. All right, $47.95 for 7 hours work. Find the rate in dollars per hour. So we want dollars on top. $47.95. Dollars, have the unit, dollar, and then 7 hours. And we want 1 hour. Okay, hopefully you're understanding we're going to be dividing by 7. So 47.95 in your calculator divided by 7 comes out to be $6.85 per 1 hour. Number 4, 1 dozen. 1 dozen, I just want to make sure that everybody's okay, that 1 dozen means 12. So be careful on that one, okay? Cost per bagel, we've got $5.40 for 12 bagels. Okay, so that's going to equal, I want it to equal 1 bagel. So $5.40 divided by 12, we're going to divide by 12 on this one. And that comes out to be 45 cents a bagel. Okay, you can either write it like this, $.45, that means 45 cents, or you could write 45 with a cent symbol after it. All right, number 5, 1987, $19.87 for 5 pounds of turkey. Find the rate and cost per pound. So we want the cost per pounds. All right, if we divide by 5, we're going to end up having roughly, it does not come out evenly. Let me get my calculator up and running. Calculator up and running. I'm going to pop in a 1987 divided by 5. 3.974. Okay, now in money, we don't write money like that. We write it to the nearest hundredths. So we need to look at the next digit, 4, which means we keep that 7 a 7. Okay. 3.97. I'm going to write these squiggly, that squiggly equal sign. That means roughly. I rounded. I took some precision out of it. All right. 5 ounces of chicken for $2.59. Find the cost per ounce. Careful on this one. Do you see that they flipped things around on you? Don't assume your first thing goes on the top. They want cost per ounce. So cost goes on top. Per ounces on the bottom. And then we're going to have 1 ounce by dividing by 5. Okay, and it looks like we're going to be roughly again. $2.59 divided by 5 comes out to be roughly 52 cents per ounce. And again, I rounded that. Okay, 5.5 blankets in 11 hours. Find the rate in blankets per hours. 5.5 blankets per 11 hours. And we want to know 1 hour. Okay, so if we divide 5.5 by 11, we're dividing by 11 here. That would be half of a blanket. Blanket, I misspelled blanket, there we go. All right, 2.2 liters of soda for $4.07. Find the rate in cost per liter. Be careful, they switched it around on you. Cost goes on top in this case. Doesn't say liter per cost, it says cost per liter. 2.2 liters. Okay, we want 1 liter. All right, so we're going to divide by 2.2. Okay, so this one's ugly. 4.07 divided by 2.2. That comes out to be $1.85. All right, so now that you've got the idea of doing 8 of these, we're going to be comparing 2 different things to see which one the better buy is. Okay, so we've got Jean selling M&Ms to friends at 4 of them for 5 cents. The machine at the store sells 9 for 25 cents, which is the better deal. All right, it's really important to understand that you can either set up money over M&Ms or M&Ms over money. This is a very key concept. Try to understand this. Okay, if you set up money over M&Ms, we want 1 M&M on the bottom, right? If we want 1 M&M on the bottom, isn't the better deal for 1 M&M the smaller amount of the price, the less money? Okay, if you set it up the other way, M&Ms over money, and we get $1 on the bottom, aren't we looking for the greater amount of M&Ms for $1? Okay, so it doesn't matter which way you put the units, but you need to think about, before you answer, which one is the better buy depending on how you set those units up. Okay, So I'm going to go ahead and I'm going to set up money over M&Ms. Okay, I've got 5 cents for 4 M&M. That comes out to be, okay, and this is a weird decimal answer for money, but I have to put it down so I can compare it with my other decimal answer for money. You get 0.0125, so that's like a little bit more than a cent for 1 M&M. Okay, this is Jean. Now the store is going to be 25 cents for 9 of them. So I want 1 M&M. If I divide by 9 here, I get this other ugly money number. Okay, now think about it. For 1 M&M, doesn't it make sense that we want the cheaper price? We want the smallest number on top to be the best buy. Okay, so Jean has the better deal. Since, and always give a reason, since it's cheaper per M&M. Okay, if you did the units the other way, you would still say Jean has the better deal, but your since would be you get more M&Ms for your buck. Okay, do you see the difference between the two justifications? Okay. All right, if you want to try number 10 and 11 without me and then check, give me a pause. Okay, if not, stay with me. Frosted Flakes, 11 grams of sugar per ounce. Raisin Bran, 13 grams of sugar per 1.4 ounces. Which cereal has more sugar per ounce? We're looking for more sugar per ounce. Okay, and notice that they tell you the way that they want the units to go. Sugar per ounce. So I'm going to set up sugar on the top, ounce on the bottom. Okay. So let's do, I'm going to change into pink so it doesn't blend in with my stuff I just wrote on the other one. Frosted Flakes. Frosted Flakes, I have 11 grams of sugar per 1 ounce. Okay, how awesome that they handed me the unit rate. Okay, over here, we had to find, they gave me a rate, and we had to find the unit rates. Frosted Flakes, they gave me the unit rate. Okay, now for Raisin Bran, we need to do a small calculation on that. 13 grams of sugar over 1.4 ounces. Okay, if you divide 13 by 1.4, you get roughly, and I'm estimating because this was an ugly number in my calculator, 9.29 grams of sugar for 1 ounce. Okay, the question was which cereal has more sugar per ounce? Frosted Flakes does because it's 11 for 1, where this one's only 9 something for 1. Okay, so Frosted Flakes has more sugar per ounce. Okay, and the work that I have here shows, justifies that statement. So that's perfect. Okay. All righty, number 11. Tom sells baseball cards at 10 for 35 cents. Is that a better deal than 12 for 40 cents? So again, it doesn't matter if you do money per card or card per money. But let's talk about the difference. If you do money per card, aren't we looking for the smallest dollar amount to be the better buy? Okay. If you do card per money, aren't we looking for the larger amount of cards for that buck to be the better buy? Be careful about that. Okay. All right, so we've got, I'm going to go ahead and do 35 cents for 10 cards. All right, that's going to get me 0.035 cents for one card. The other deal was 40 cents for 12 cards. That's going to be 0.033 cents for one card. Okay, so the better deal is going to be paying 40 cents for 12 cards because it's cheaper per card. That's your reason. Okay, so 40 cents for 12 cards is the better deal since it's cheaper per card. Okay, how'd those comparisons go? All right, on to the next page, you guys. We've got 3 more to compare. Let's see here. I'm going to go ahead and do them. We won't have anything as fancy as number 13 on this lesson. We will not have anything as fancy with this conversion to think about also. But I'm going to go ahead and do them. Okay. If you understood number 9, 10, and 11, you probably don't need to sit through these 3. If you were kind of starting to get it on the 11th one, maybe you want to see at least another one. Okay. So feel free to scooch me forward and get on to this next number 15 if you want to skip. Okay. All right. Hardware store sells 4th of July sparklers for 19 cents each. The fireworks stand charges 85 cents for 4. Where would you purchase sparklers? So we're looking for the better deal. Okay. So we've got a store. We've got a store and we've got a stand. Okay. The store is 19 cents each. And I love sparkler. I love that it just hands us the unit rate. We don't have to do anything on that one. Okay, now the stand, we have to do a little conversion on this. We have 85 cents for, how many of them? 4 of them. We want to know what one sparkler is. So we're going to divide this 85 cents, 0.85 by 4, and it comes out to be roughly, it's not an even number, 21 cents. Okay, so I would rather buy them from the store because they're cheaper per sparkler is my reason. Okay, buy them from the store since they are cheaper per sparkler. Okay, if you did the units the other way, sparklers per money, aren't we looking for the greater amount of sparklers? So you would still say buy them from the store since, but you would say you get more sparklers for your buck. Okay. All right, this guy, ribbon. We've got 5 meters for $6.45, or we've got 240 centimeters. Careful, we've got meters and centimeters. We can't compare those. We need to convert one of them. So I'm going to take this 240 centimeters and I'm going to divide it. I'm going to think about the conversion for that. So 1 meter is 100 centimeters. Okay, so that's going to be 2.4 meters. Okay, so I'm going to be using 2.4 meters and 5 meters since my centimeters has been converted. I need them both in the same unit. I will not be giving that to you on your test. Okay, all right. All right, so we've got, let's see, the $6. I'm going to put money on top. Doesn't matter which way you put it. Let me change it to pink so it doesn't blend in with that one I just did. So $6.45 for 5 meters. That gets us, when I put it in my calculator, let me see what I got when I did that one. I got $1.29. Okay, and then the other deal was, what was it? $3.19 for 2.4 meters. And this one came out to be roughly, I rounded, $1.33 for 1 meter. Okay, so the better deal is going to be the cheaper amount on top. If you did it the other way around, you're looking for the larger number of meters for your buck. Okay, so 5 meters for $6.45 is the better deal. Since it is cheaper per meter. Okay. Number 14, an 11-ounce can of condensed soup, add 1 can of water, don't be tricked, costs $1.45. Okay, so how many ounces are you really getting for that $1.45? 22, right? If we have an 11-ounce can of condensed soup and you add a whole can of water, that's another 11 ounces, so 22 ounces. That's tricky. I will not be tricky like this on the test, okay? All right, let me switch back to my blue. All right, so we've got $1.45 for 22 ounces, and we need to see how much that is for 1 ounce. And that comes out to be, and I'm making this a very ugly number, but we need to carry out some digits to be able to compare, 0.659. Okay, and then we've got this $1.29 for 20 ounces. That's ready to go the way it is. For 1 ounce of this, it comes out to be 0.0645. Okay, now money per ounce, we want the cheaper one. Okay, now if you didn't carry all these digits, they would look like they're the same, 6 cents. 6 cents an ounce, but that's not true. Okay, this one's cheaper because it's 6 cents. It's with the 45 and this has the 59. This is the smaller number. Okay, so 20 ounces for $1.29 is the better buy. Since it's cheaper per ounce. All right, there were your compares. Okay, now let's get into these guys. These guys down here, activity 2, using these unit rates, these are really important problems, and you're going to have these on your test for sure. Okay, now we've got 1, 2, 3, 4, 5 of them. Okay, it's pretty fair to say if you understand the first 2, you're good. Okay, but I will work through the 5 of them. If you understand the first 2, you can be done with these notes. Okay, if you're just starting to get it on the second one, or the second one confuses you, you probably want to stick around for the third one and see how you feel. Okay, all right, let's look at this guy. Use the tables to identify the unit rates, then use the unit rate to answer the question. Okay, so identify the unit rates. Remember, there are 2 unit rates from the last lesson we did. Okay, so I'm going to go ahead and I'm going to look at, it doesn't matter which one you look at. I'm going to look at this one. So I've got 2 cups flour for 12 cookies. I want to know how many cups of flour for 1 cookie. Okay, so if I divide by 12, I would have 1/6 cup of flour for one cookie. Okay, if I flip these around to find the other unit rate, 12 cookies for 2 cups of flour, how many cookies for 1 cup of flour? I'd have 6 cookies. Okay, so here is one of my unit rates and here is my other unit rate. It's very important to understand these are rates, and these are unit rates. Do you see where the 1 is in the unit rate? It's in the denominator. Okay, and if I used any one of these pairings, I would have gotten the same unit rates. Okay, all right, what is the unit rate of cups of flour per cookie? Right here it is. So 1/6 cup flour per cookie. Okay, and remember, you can choose to write it like that, or you can write it like that. It's the same thing, I'm just kind of squinched on space. How many cups of flour would be used for 20 cookies? Okay, if you know how much flour you need for one cookie, wouldn't you just take 1/6 cup flour for one cookie if we're trying to find 20 cookies? What happens to this? 1 to 20. Aren't we multiplying by 20? So we would multiply this by 20. We would multiply that by 20. Let me write that in. Multiply by 20. Multiply by 20. So we would have 26 cups of flour, which is equal to, I would accept either 10/3 cup flour or 3 1/3. Okay, that's your answer. Okay, your answer is not this rate. The answer is how many cups of flour? 10/3 cups of flour or 3 1/3 cups of flour. Okay. All right, what is the unit rate of cookies per cups of flour? Cookies per cups of flour right here. Okay, if I write small enough, I can write it as a fraction. 6 cookies for 1 cup flour. How many cookies could be made with 5 cups of flour? So let's write down our unit rate. And we need to get 5 cups flour, which means we're multiplying this by 5 and this by 5. Okay, please don't leave your answer like this. You haven't answered the question. It says how many cookies could be made with 5 cups of flour? 30 cookies could be made with 5 cups flour. How many cookies could be made with 0 cups of flour? 0 cookies are made with 0 cups flour. Okay, if you understand that one, you're going to be great on the test. Okay, let's do another. All right, inches of snowfall and hours. So it says, what is the unit rate of inches per hour? What is the unit rate? So we're going to be asked for both of them, and we can either do them both off to the side like we did on the last one, or we can just figure them out here. I'm just going to figure them out here. What is the unit rate? Unit rate of inches per hour. So I'm going to take one of these. I'll take this one. Inches. 1 inch per half hour. Do not think that because there's a 1 in this, that's the unit rate. Remember, the 1 has to be on the bottom. Okay, how do we turn a half into a 1? We multiply by 2. Okay, so we would have, hold on, did I do that right? Yeah. So I would have 2 inches per 1 hour. Okay, at this rate, how many inches of snow would have fallen in 2 1/3 hours? All right, well, if we have 2 inches for 1 hour and we want to know 2 1/3 hours, aren't we going to multiply this by 2 1/3 and this by 2 1/3? 2 1/3 multiplied by 2, 2 1/3 multiplied by 2. 2 1/3 would be 7/3, right? Yes, 7/3. Okay, so that comes out to be 14/3 you could put here. Or you would say, how many is that? 4 2/3. Okay, either one of those, 4 2/3. So I'm going to put 4 2/3 inches. Okay, this, my friends, is not your answer. How many inches of snow? So I'm going to put 14/3 or 4 2/3 inches of snow falls in 2 1/3 hours. That's the answer. All right, what is the unit rate of hours per inch? Well, that one's a little nicer. We've got 1/2 hour per 1 inch. Guess what? That's already a unit rate because the 1 is in the denominator. At this rate, if there is 7 inches, 7.5 inches of snow, how long has it been snowing? All right, so if I have half of an hour for 1 inch and I want 7.5 inches, aren't I multiplying the top and bottom by 7.5? Multiply by 7.5. All right, so off to the side here, a half times 7.5 would be 15 halves. That comes out to be 15 fourths, or 3 3/4. Yes. Okay, that would be 3 3/4, and then this would be hours, 3 3/4 hours for 7.5 inches of snow. This is the answer to that problem. How many inches will it snow in 0 hours? 0 inches of snow in 0 hours. Okay, next one. What is the unit rate in pesos per dollar? I'm going to take these here. Pesos per dollar. So 60 pesos in $3. If I want $1, I would have 20 pesos. Okay, at this rate, how many pesos is equivalent to $8? Well, here's my unit rate. 20 pesos is $1. And if I want $8, I would multiply this by 8. So 160 pesos. Okay, what is the unit rate in dollars per pesos? So I've got $3 for 60 pesos. And I want 1 pesos. Peso. All right, so I'm going to divide by 60 here. If I divide by 60, 3 over 60 is 1/20 of a buck. Okay, that looks a little strange, but that's the unit rate. At this rate, how many dollars is equivalent to, wow, okay, 118.60 pesos. All right, so if I have 1/20 of a buck for 1 peso, and I want to get 118.60 pesos, I'm going to multiply this by 118.6, 118.6. And when you do that, it comes out to be $5.93. This is not the answer. Okay, you would say $5.93 is equivalent to 118.60 pesos. That's the answer. If you have 0 pesos, how many dollars is that worth? Nada. Okay, 0 pesos is $0. All right, you guys, the last two. If you feel like you're good, you don't need to watch these last two. Okay, it's the same thing. Okay. All right, we've got home runs, we've got swings. What is the unit rate of home runs per swings? I'm going to use this. 1 home run, I'm going to use HR over 7 swings, and I want 1 swing. Do not think this is a unit rate because there's a 1 in there. The 1 needs to be on the bottom. So this is 1/7 of a home run. At this rate, if the batter swings 30 times, approximate the number of home runs he would have gotten. Okay, so we're going to have 1/7 home run over 1 swing. And if I swing 30 swings, I'm going to multiply this by 30. That would be 37ths home runs. Okay, well, 37ths home runs, that's about 4 home runs. Runs for 30 swings. Okay, this is your answer. This is not your answer. What is the unit rate of swings per home run? Well, that one's nice because we have it already with a 1 in the bottom. At this rate, if they have gotten 9 home runs, how many times did he swing? So we're going to use our 7 swings in 1 hour. Not swing, sorry. Not hour, home run. Gosh. One home run. Okay, and we want this to be a 9 home runs. We're multiplying by 9. So 63 swings. Okay, this is not your answer. We have to answer the question. How many times did he swing? He swung 63 times. How many home runs does the batter have after 0 swings? 0 home runs after 0 swings. Okay, let's look at this guy. What is different about this table? Okay, well, looking back at all the other problems, I haven't seen a 0 in any of these tables. Okay, so it charges $45 for 0 hours. That hasn't been the case in the others. Okay, is there a unit rate? Okay, this would be 45 over 0. This would be 70 over 1. 95 over 2, that would not be 70 over 1. Okay, so no. Each relationship does not simplify to the same unit rate. All right, our focus is not going to be on 19. That's going to be a huge focus of your 8th grade year. Okay, but we will be talking about the meaning of that just a little bit this year. All right, thanks for staying with me, you guys. That was a long lesson. Thank you.